Okay, so the next step is a terrain correction. And I won't lie that terrain corrections have always scared me in the past, mainly because we learned about those charts when I was at varsity, and it seemed like a lot of work. So I did the lazy approach of always saying, well, there's not much terrain in our area. It's not so serious. But yay for Geosoft and being able to push a button. And you can see on the gravity menu, terrain correction is first before you do free air. So if you want to read up more about it, please do go look at the tutorial. It's page 62. Great information about airborne surveys, marine, ground surveys. The big thing here is whether you need a regional grid or not. And obviously a regional grid could probably be a bit lower resolution than the local grid that you need. So for this survey that we're doing it just using a local grid. So if you're doing a larger area or tying in multiple surveys, you would want to go and look through this on how to create a regional grid. But yeah, we are going to just do a smaller grid. So you're going to click here on gravity. You're going to click on terrain correction. So this merge DEM and bathymetry. It also links with setting up your grid, your elevation grid for your area. So ours is already set up. So I must admit I haven't exported much, and we're not using this regional correction. So I was a bit lazy and did it very fast and just used the tutorial data. I'm going to click on terrain correction. So elevation channel over here. From what I understand, but again, please go read the tutorial. If you were using airborne gravity, this is going to have to be the height of the gravity meter in the airplane. Topography, so this is DEM, top of rock. I haven't actually compared. It's interesting. This DEM is a lot lower resolution than this elevation. So, I mean, technically elevation should be to the center of the gravity meter and topo should be to the center of the rock. Something I can show you. I did create some plots just to get an idea of the different data sets I was working with. And so you can see here, this one, let me make it bigger. This is this DEM file in the background. You can see how low resolution it is. And this colorful image down here is the local elevation data that was collected. I've even got it here. That was collected, I assume, from something else, since there's no data points outside this side. But anyway, it's just to give you an idea of the different resolutions of the two databases. So I feel like I haven't really answered any questions, answered myself here, the difference between the topo and the elevation. So just looking back at the tutorial, I might be absolutely wrong, but just to show you, if it was an airborne, it says a local DEM should be the topography and station elevation should be the flight elevation. But here for a ground survey, which is what we're doing, it doesn't really talk about a difference. It says local DEM should be combined with land and bathymetry elevations. Station elevation channel can be land elevations. So my reading is that it's the same thing, but anyway. Okay, so correction distance, they estimate up to, well, they suggest 50 kilometers away, which is huge. So I shouldn't have been saying that I could ignore the terrain correction in my area, because I'm sure there's terrain up to 50 kilometers away. Earth density, the main thing I just wanted to say here, when we later do the Bugay correction, they said for the complete Bugay correction, this density and the density you use in that correction should be the same. So just keep that in mind. Water reference datum. Again, I'm sorry, I didn't engage with this much because there wasn't a lot of water in the area we're looking at, but there's this grid that they've created, contact with air, for your water reference datum, or you could use a constant. Please investigate that more. The bathymetry channel is the water channel, water density 1. So I'm sorry, I didn't investigate that more. I should really study terrain corrections. And then output terrain correction channel is terrain. So can I just say this, something that confuses me, but this terrain channel already exists, and I think it's because it's something that the CG5 can calculate, I assume, so that's why it outputs it, but we are now calculating the correction and putting it back into that channel. If that doesn't make you feel good, you can also just call it something different, terrain correction. And I've left this blank. They said you could if you're not doing the regional correction. So I'm going to click OK. Takes a bit of time to calculate. Okay, and here's our terrain correction. Again, nothing too huge. I mean, biggish values, so you can see the importance of actually doing them. I mean, if you compare them to your drift correction here, the drift is 0.0 something. Here we've got a few 0.1s, so quite important. Okay, so now we have a terrain correction channel. And now we can move on to our free air and bouquet correction.